So good Wednesday afternoon, everyone. Welcome to first lecture in mathematics for construction in the BTech and the civil engineering. We want to talk about some basic things in math today, right? Before we start to do anything advanced. The link to the course notes online is this link up here, which I shared in the Zoom chat. This link will not change. All right, this link up here will not change. It's a link to your notes for the course. I will post up links to the YouTube playlist, which would have all the recordings for the class. That link will not change either. It's a playlist. A playlist is a combination of videos. So as soon as we finish a lecture and I record the video, I will put that video on the playlist. And I will just send you all a message on WhatsApp indicating that I've uploaded the recording for today's class. I have everybody's contacts. I will create a new WhatsApp group and I will add everybody to it, including myself. And I will communicate with you primarily through that medium, right? So everything is online. Everything, your notes is on Notion here, as you see, this page. And all your videos would be on YouTube. And the links will not change, of course. So usually we're gonna have class on Thursdays, but today's class is on a Wednesday. Today's Wednesday. I have a problem sheet I put up here for you with a lot of SEA type questions, right? If you click on it, you would see these are the kinds of things that I need you to be able to do. So go through this and make sure you could do these problems here. This is SEA/CXE CSEC level. And we can go to lecture 1. So every time we do a new lecture, you'll see another lecture in this list here under class notes. So lecture 1, right? Fractions review. Can you all see my screen? Or is it too small or is it too big? Is it good? It's good, right? So a review of fractions, we want to review some basic techniques from primary school, from SEA, right? When you are a child, how you add fractions. So the dominant way of doing this is to use things called LCM and to draw a line and all these kind of things, right? That's actually not the best way to add fractions. You really shouldn't do things like that anymore. We want to use the concept of equivalent fractions, right? So the idea really is you represent each fraction as a fraction with the same denominator. Okay, so here a half, okay, I could multiply above and below by the same number. It doesn't change the fraction, right? So a half is this here. Let me take this out, right? So a half, 1/2 is actually 2/4. We can multiply above and below by the same number, okay? So this is what I mean by equivalent fractions. A half is actually 2/4, okay? So the idea is you can multiply above and below by the same number and not really change the fraction. Fraction is the same. 1 part out of 2 is the same as 2 parts out of 4. For those who are familiar with ratio and proportion, parts of a whole, if you divide something into equal parts, we could see this happening. Also, you know, a half, we could represent it differently. If we multiply above and below by, say, 3, we get a half is actually 3/6. So these things look different. 2/4 looks different to 3/6 looks different from a half, but they're all the same fraction. As essentially what equivalent fractions are, okay? Now, it doesn't work the same way by adding. You can't add the same number above and below. It doesn't work like that, right? You can multiply above and below by the same number. That wouldn't change the fraction. But adding the same number above and below doesn't, it actually changes the fraction. So we don't want to add or subtract. We want to multiply, okay? So if we have this question here, if we have a half plus if we have a half plus a quarter, that is the same as 2/4 plus 1/4. Okay, so we change a half into a fraction that has 4 as the denominator. There's the same fraction, and therefore this here is 3/4. Okay, once the denominator is the same, we add the numerators. Okay, so one way of seeing this a little bit better is like this. Okay, once the numerators are the same, we just add, well, sorry, once the denominator is the same, we just add the numerators. So 2/4 plus 1/4, that's 2 plus 1, 3/4. Okay, so we don't really need to work with LCM. We could work with any common multiple. We use 4 for the first question, a half plus a quarter, because 4 is the LCM of 2 and 4. But we didn't need to use LCM. You could use any common multiple. For example, I could use 8. A half is 4 parts over 8. A quarter is 2 parts over 8. So if I convert them to equivalent fractions with the denominator of 8, I have 4/8 plus 2/8, that's 6/8. And 6/8 naturally reduces, so you'll get 3/4. So this shows any multiple would work, but using the LCM is a little bit easier because the LCM is the smallest number that is a common multiple. And humans like to work with as small numbers as possible in our head. It makes the mental work a little bit easier, right? But the mathematics shows you that there is no reason really to use the LCM. Any common multiple would work. The nice benefit about this approach is that you don't need a working column, right? We want to avoid working columns where you question here, but you answer somewhere else. A teacher or a marker shouldn't have to be looking all over the place for your working. Your working need to be where the question is, right? So you need to show all your working up front and center in the middle of the question. Here, I don't have a working column. All my working is in place right here. Okay, so it might take some adjustment on your part to get used to it, okay? So I just pretty up the notes here for you guys. You see this diagram shows you that 1/3 is 2/6 or a quarter is 2/8, right? Using the example of a pizza in a sense, okay? You divide the pizza into equal slices. 4 parts out of 8 is really 1 part out of 2. That's what we see in here. So to do something like a half plus a quarter, you can't add them unless the numerators, sorry, the denominators are the same. So you can't just add 1 and 1 to get 2 and 2 and 4 to get 6, and the answer is 1/3. Fractions don't work like that. So you need to learn a very simple technique to convert one fraction to another equivalent fraction, right? So if you have a question like a half plus a quarter, you can do this different ways. So how you would do this question here using the same technique? 5/6 minus 3/4. What is the answer for this question here? Using equivalent fractions. How would you do this? Try this one for me. So for a question like this, what you would want to do is both fractions have different denominators. So we can't subtract them directly. And 4 is not a multiple of 6, 6 is not a multiple of 4. So we need to find some common multiple of these two numbers. The LCM could work as 12, right? We could represent both of them with the denominator of 12. 5/6, to go from that to something over 12, we need to multiply above and below by 2. So 2 5s are 10, right? And for the 3/4, to go from 4 to 12, we multiply by 3. So we get 9/12 here, right? And the answer for this 10 minus 9. Okay. This is how you would do a question like this. And again, the nice thing is you don't need a working color for this. So let's see if we could get a question from the working, say our worksheet here. We have some questions in here. Some of them, they look kind of hard, right? Let's try this question here, 24. The first step you should do is convert all mixed numbers to improper fractions, okay? And then we do BODMAS. BODMAS, you do the brackets first, and then multiplication and division. When you have no brackets, you usually multiply before you add or subtract. Multiply and divide is essentially the same thing. You do that first before addition or subtraction when you don't have brackets. When you have brackets, you have to do the brackets first. So try this question here, convert everything, all mixed numbers, convert them to improper fractions. That way you don't have to memorize crazy rules or how to add or subtract mixed numbers from other mixed numbers, okay? So first step is to convert the question by converting all mixed numbers to improper fractions. So this 1 1/4, this should really be 5/4. Okay. So I just rewrote the question. It's 4/3 multiplied by that there. And now the stuff inside brackets, you convert that to equivalent fractions, right? So you have 1/4 minus 1/5. A common multiple is 20. So this is 5/20 minus 4/20. Okay. So you'll get 4/3 by 1/20. So we have to do brackets first. So if you multiply 5 over 4 above and below by 5, you'll get 25 over 20, right? And if 1 over 5, you multiply above and below by 4, so you get 4 over 20. So this should be 4 over 3 by 20, 1 over 20. Now we could cancel, right? We have different ways of showing how to do this. So 3 into 3, 1, and 3 into 21, 7, right? We could cancel the 4 as well. 4 into 4, 1, and 4 into 20 is what? 5. So we have 7 over 5. You can leave your answer like that. In fact, you don't need to write it as a decimal. You don't need to say, well, there's something, point something, you know. 1.4, whatever like that. You shouldn't really work with decimals unless you have to. And you really shouldn't work with mixed numbers when you have a fraction question. You should give your answers as improper fractions. So this is fine. Okay, so I have this question here. It might be a little bit small, so I could probably increase the size a bit for you all to see. Try this question here, use any techniques that I've shown you, equivalent fractions. You want to convert all mixed numbers to improper fractions. Then you use equivalent fractions. Then you work out brackets first. You know, then you follow BODMAS. You do multiplications before additions when you have no brackets. And in the end, you might have to invert and multiply. So this question is a couple lines. Take your time and do it and tell me how it goes. So the first step is we want to rewrite the question, but change all improper fractions to change all the mixed numbers to improper fractions. So, all right. So let me see. So 2.5 is 5 over 2. 1 3/5 is 8 over 5. Okay, and the bottom two fractions, the 5 over 6 minus the 3 over 4, we could go ahead and try converting that to equivalent fractions. So I could do a times 2 here. And the 3/4 is times 3. Okay. So here I'm showing my working. I don't need a working color. The numerator went from having mixed numbers to improper fractions. So when I see something like that, my cue is, okay, well, this person converted the mixed numbers to improper fractions. In the denominator, so the 5 over 6 and the 3/4, it changed to add things to it. what I'm doing is I'm multiplying above and below by the same thing, but different numbers for each fraction. The aim is to get the same denominator, which is 12, okay? So now I could do the same thing with the numerators. Let me fix up the denominator here. This is 9, this is 12, this is 10, and this is 12, right? And on top, the 5/2, I could convert both of them to equivalent fractions. So I'm using 10 as the denominator. So multiply above and below by the same number. Okay. So 2 by 5 is 10 and 5 by 2 is 10. So I multiply above and below by 5 and above and below by 2 here. So this is 25 over 10, 16 over 10. And then this down here is 1/12, right? I could remove the brackets here. So we say we doing each time you rewrite the question, you're doing something different. Here I see the 10/12 minus 9/12 changes to 1/12. And up here I see I do the work in 25/10 minus 16/10. So rewrite the question. The last point where I am. 25 minus 16, this should be 9. 9/10. And the bottom 4/5 by 1/12. This is 1/15. Okay. And then you invert and you multiply. So 5 into 10, 2, 5 into 15, 3, 9 3s, 27. over 2. And so just to space out the working a little bit more here. This is the final answer. You can leave your answer like that. I don't need a working column to do these types of questions if I do it like this. All my working is shown in place, right? Where I'm actually doing the question, all the working is self-contained, okay? This is why I prefer you all to do it like this, because when we do more advanced math, we will be doing larger, more difficult problems where the working going to be a page or two. And you can't have a working column in cases like that because you don't want the person to have to look all over to find your working, okay? So the idea is all your working should be done in place in the question itself as one continuous flow, where you rewrite the question, you rewrite the equation or the expression several times, and each time you do something different. You do one small step. You could do a small step in the numerator and a small step in the denominator, and then eventually you will arrive at an answer. And by showing all your work in here, you get full marks, okay? So I have this question here. 4 over 13 multiplied by brackets, 3 and 2/5 minus 2 and 3/4, close brackets, as a numerator. The denominator is 2 and 1/3 minus 1 and 3/5, in brackets, all divided by 22 over 3. So you have to take your time with this question, right? You see how I did this one before. First step, convert all mixed numbers to improper fractions. Second step, take care of your brackets. You gotta look at your brackets. If your brackets have fractions being added or subtracted, you want to use equivalent fractions and you want to work out each bracket separately, right? When you finish work out your brackets, then you have no brackets. So you have to use the rules of BODMAS, which says when you have no brackets, you need to do multiplication or division first, then do addition or subtraction. And when you divide by a fraction, like you see here how I divided by 1 over 15. Dividing by a fraction means invert the fraction and multiply. So you see I multiply by 15 over 1. So something very similar gonna happen down here, right? With this question. So try this question, take your time. You could private message me in the Zoom chat your answer. Don't public message me the answer because other people might see it and I may not want to do the question. But the purpose of me giving you these questions is to practice. And when class finished today, you'll go back to this worksheet here. You'll have access to this fractions worksheet. And you have 50 questions with answers that I want you all to sit down and try to do. I will give you homework too that have more interesting, slightly harder questions to do for homework, right? So the idea is to get as much practice. This is a very hands-on course. I don't really expect you to sit down and watch me teach a class because I don't really have a lot of teaching to do. I teach something for 5 minutes and give you a question and you have to do it. So have fun with this. I hope you get it right. So, okay, let's do this question. First step, rewrite the question and change mixed numbers to improper fractions. So 3 and 2/5. That is 17 over 5. 2 and 3/4. 2 4s are 8. 8 and 3 is 11. So 11 over 4. For the denominator, 2 and 1/3 is 7 over 3. 7 over 3. 1 and 3/5. That's 8 over 5. Okay, so that's the first step. Second step is, well, let's deal with the brackets. Now we could work out the brackets in the numerator and denominator at the same time, okay? So what I would do is, when I look at the brackets, and the brackets have subtraction of fractions with different denominators. So I know how to do equivalent fractions here. So I rewrite the question, and this 5 and 4 here, change them to 20, okay? So 17 by 4 times 4 and 11 by 5, right? And again, you don't need to show this. I'm just doing this here in case anybody wants to know how I get these numbers, right? So I multiply above and below by the same number. The aim is to convert both fractions to something over 20, because only then we could subtract them. Now, you don't need to do that to multiply fractions. Yeah? As if you notice up here, like when I had to multiply 9 over 10 by 15 over 1, I didn't go and convert both of them to a fraction with a denominator of 10. Multiplying and dividing fractions, you don't need to work in equivalent fractions. Equivalent fractions, you only need to do that when you're adding or subtracting fractions, okay? Just to be clear. This 7 over 3, whoa. 7 over 3 and 8 over 5. 3 and 5, I should probably work with 15. So multiply by 5 here, and maybe 3 times 5. And the 8 over 5 multiply above or below by 3. So this looks good, right here. You're seeing all these steps, right? So let me rewrite this question now. So rewrite the question. Take out this equal sign here. 17 by 4. Well, 7 4s are 28, and 10 by 4 is 40. So 40 plus 28, that's 68, right? So all this up here is 68 over 20. And this is 55 over 20. The bottom, this is 35 over 15. And this is 24 over 50. Okay, so that's enough working for that part. You want to rewrite this question now and just do something different. So 68 minus 55. 55 and how much is 68? 55 and 10 is 65. 65 and 3 is 68. So that this is 13 over 20 here. Right? So I could write this as 13 over 20. And I could take out these brackets here. Now I just have fractions. 13 over 20. And then the bottom here, 35 minus 24. 24 and 10 is 34 and 1, so that's 11. So this here looks like 11 over 15. And I could take out this right and this left bracket. Okay. So I have a nice, simpler looking answer here. We could do something with the numerator. So let me write it back. The 13s could cancel an numerator. We cancel that 13. So I'm gonna put that here. So we cancel the 13, right? The 13s cancel. The 4 cancels with the 20, okay? So 4 into 4, 1. And 4 into 20. Five times, right? So up here looks like 1 over 5 in the numerator, right? To the bottom, what I could do is just, instead of div, just say multiply, and you flip it. You flip it, right? So this is 3 over 22, okay? So I did one step in the denominator, I just flip the 22 over 3 and multiply. That's the one step in the denominator from here to here. And from here to here, I just cancel. Okay, the idea is do one step at a time for each part. So in the numerator, I should have 1 over 5 upstairs there. So I have 1 over 5 on top here. And down here, we could cancel some things, right? Let me see. Down here, the 11 can cancel with the 22. 11 to 11, 1. 11 into 22, 2. Right? And 3 into 3, 1. 3 into 3, 1. 3 into 15, 5. Okay. So the bottom here looks like 1 over 10. That's what the bottom here looks like. So this could be, hold on. One over 5 divided by 1 over 10. Oops. And then if you have 1 over 5 divided by 1 over 10, you just invert and multiply. So that's 1 over 5. And we invert 1 over 10 and we multiply. So what we get, we multiply by 10 over 1. And at this point, it's kind of easy, right? 5 into 5, 1, 5 into 10, 2. So the answer is 2. But if you want to see it, 5 into 5, 1. Okay. And that's it. So, I mean, I kind of made it fit in 2 lines, but if you're actually writing this out in a textbook, sorry, in the actual notes in a fuller page, it's gonna be probably a line for each step. So I could say 1, 2, 3, 4, 5, 6, 7, 8, probably around 6, 5, there's more than 5 lines, 5 to 7 lines, somewhere there is the full solution to this. And even though this is a fractions question, it's actually important to know how to do this very efficiently in one line in place rather than having a working column. It's very important to do this in line where all your working is in one spot, because as I explained before, when we come to do more advanced questions in this course, your answer going to be like 35 lines and 5 of your 35 lines going to be something like this. This is actually not going to be a legitimate question in your assignment. This is going to be part of your question, a small part of the overall question, where you have to do some calculation and work it out. But you need to know how to do it properly. And this technique here shows you how to do these things with great efficiency, okay? So I hope you all understand this and I hope you all got it right. So we want to talk about the course outline, what this course is about. I will type up some of the important text in this document here, and I will put it on the homepage for you all in the next couple of days, right? You all will have access to it. Essentially, you can ignore this, you know, I will take out all the codes and all these weird things that you are probably not going to understand, right? Is a level 4 course and has 15 credits. These things they will explain to you when you do introduction to BTech. Okay, most likely you have a course called Introduction to BTech, something like that. They will explain what these things mean. Let's read the introduction. Aim of the unit is to develop student skills in math principles. These principles underpin construction, civil engineering, building services, okay? You'll be introduced to many mathematical, statistical techniques, and it will help you to analyze and solve problems within the context of construction engineering, okay? Topics included, you know, everybody love these topics here: trigonometry, algebra, right? We're gonna be focusing on algebra for a good while. We'll touch on matrices, right? Statistical techniques. We'll do some calculus, so differential and integral calculus. Binomial and normal distribution. This is something that you would not do in ADMATS if you did ADMATS. APs, arithmetic progressions, some vector analysis here, dimensional analysis. Some of these things you would have done if you did ADMATS, but even ADMATS sort of wouldn't do like 2 or 3 of these topics here, right? Basically, all these topics here assumes you did CSEC maths or O levels or CXC or, you know, whatever they call it now, right? So successful completion means that you know how to use these mathematical techniques and in further courses. So you're going to be doing courses about civil engineering, but the course is going to have math inside of it. You're going to have to do calculations, model something, solve some problem using these math techniques. So your other lecturer is going to assume that I teach you these techniques. In fact, they're going to ask him, Munish, show you this, right? And you'll be like, yeah, you know, he actually do that, forget, right? So they'll call you out. They will call you out in courses to come. But that's why this course is first. You do a math course first when you're doing engineering because all the other courses depend on it. That's just the reality of it, you know. Analytical computational methods, expected to know these things, how to interpret techniques, apply a calculus techniques, solve problems, you know, analysis, data. That's what I hope to get out of it. At the end of this course, they hope that you know these things here. Okay, plain and simple. What's the learning outcomes? Most of these units have 4 learning outcomes, okay? So analytical and computational methods. That's the first part of the course. We'll use some statistical techniques to interpret, organize, present data, right? Using, you know, some appropriate software packages here and there, like Excel is a good software package for data. Calculus is one of the widely used topics in advanced mathematics, right? All the engineering disciplines use it. Calculus is vitally important, but your journey to calculus is like 2 years or 2 to 3 years. You need to do something called pre-calculus. Pre-calculus is all the algebra techniques you need to learn before you start calculus. So we will do calculus towards the end, right? Is the hardest topic in the course. Things like arithmetic progressions, dimension analysis, vector analysis, these things not so bad. The hardest thing is this guy here, calculus, okay? The journey from now until you are ready to do calculus is a good while. And I will try to, you know, expedite it as much as I could. But we do have 2 to 3 years to do calculus. We have like a month, maybe 2 months, right? What does it look like? What does it look like? These computational methods. So trigonometry, that's the mathematics of triangles, right? Volumes and areas from CXC or CSEC, we did sine rule, cosine rule, area of a triangle, and how to apply it to problems, right? Civil engineering and construction is a very real engineering, right? The things you see tangible, like you see shapes in front of you and you might have to calculate area, volume, as the case may be. So these things, these problem solving techniques, are going to become very useful. This is where it started to get advanced, where it started to talk about coordinate systems and ratios and quadrants and solids, actual solids, right? We have to find volume and area of these things. The algebra not so bad, the linear, simultaneous, quadratic stuff. That's where we're heading towards. That's where we're going to spend the first part of the course doing, the algebra part of it. This part real important. This sets the stage for all the other topics, right? So we will focus on algebra basically for the month of March. For the whole of March, we're going to be doing a lot of algebra, advanced algebra. These matrices very easy. Matrices is very easy. We could do that, you know, at any point in time. Applications to construction problems. This is the more interesting part where you're actually given real problems that require the use of mathematics. Okay, you all will see that in my assignment. My assignment will look like a real world problem. Where's a lot of English words that you had to read and decipher what's going on. It's not gonna look like this here. The assignment not gonna look like this, right? You have to read the assignment and pick this out of it. You have to pick out the problem, the civil engineering problem from the assignment, and then apply mathematics to solve the problem. The assignment not going to look like this. Your answer going to look like this. I hope you all understand, right? We have lots of statistical methods. And in fact, this part, this is easy as well. This is not so hard, and any past students tend to find these things kind of straightforward. Right, you'll probably know mean, mode, and median, these things variance. You will be introduced to proper statistical techniques. What is variance, deviation, quartiles, distributions? What is a probability distribution? What is probability? What is statistics? These things. I will go into detail what these things mean. And how to apply it, right? To present data, to estimate things, for quality control and all these things, right? This is what statistics and probabilities use in the real world for. So that is what they want you to know, because you're going to use it in construction. You're going to use it in quality control and civil engineering. It's a real thing that engineers have to do. So your assignment going to have some elements of that in it, right? Yeah, let me talk about learning outcome 3. That's the hard one, right? Let me go straight to learning outcome 4. Your trigonometry techniques, right? Your vector analysis, lots of triangles, sine, cosine, tangent, lengths, that kind of stuff. Dimension analysis, not so bad. You have to know your fractions and your indices and your algebra to do that. APs is basic algebra, you know, linear factorization, simultaneous equations, both quadratic and linear, that kind of thing. Yeah, so that's learning outcome 4. The learning outcome 3 is the tricky one. This is calculus. You see these things here? These things notoriously troublesome for students. I'm not saying you're going to get trouble, but statistically, it gives a lot of people problems. These things here, we are a long way from that. If you did maths, you'll probably recognize some of these things, and you might probably remember how challenging these things can get, okay? And they're gonna put trigonometry in it, which is a special kind of difficult, right? These are real engineering problems. In the real world, we use calculus to solve these kinds of problems here. With rotating bodies, moving objects, objects at rest, statics, dynamics, equilibrium, fluids, things twisting and turning, like think about a bridge, a suspension bridge. Have a lot of calculus inside of there, in those joints and the tensions and in the struts and so on. Building a bridge is not an easy thing. Computers help us with it now, but the computers obey the mathematics that we need to understand. Okay, so fluids, structural mechanics, electrical theory, all these things use this guy called calculus, and this is a a challenging topic. To tackle calculus, you need to have a very strong foundation in algebra. Very, very strong foundation in algebra. And that's what we're going to be doing in March and April, getting that strong foundation in algebra. Okay. These are your learning outcomes here. Your actual assignment would have this to the back as the last page, where we're actually telling you what is a pass, what is a merit, what is a distinction. We're actually telling you what to do. Okay. So when you do this course, Introduction to BTech, I think you all have a course, Introduction to BTech, I'm not sure, but you should have one that explains these things. What's a learning outcome? What's a pass? What's a merit? What's a distinction? What you could resubmit on, like you can't resubmit a merit, you can't resubmit a distinction. If I give you an assignment and a part of the assignment is M1, which is a merit, and you fail to get this, you cannot resubmit that. You lose it the first time. You're only allowed to resubmit your pass outcomes, your P1, your Ps as they say. We have about 8 Ps, I think, P7, P8. Those you need to pass in order to pass the course. If you manage to get the Ms and the Ds, those are more difficult parts of your assignment. Typically, what you would find is that your pass outcomes are the easiest parts of the assignment. The merits are a little bit harder than the pass, and the distinctions are kind of hard. A lot of people don't really get the merits and distinctions because you have to demonstrate a lot more understanding of the harder parts of the course. If you just want to pass, just get your Ps, your P1 to P8, and you're good to go. If you resubmit and you fail your Ps, you fail the course. Your Ms and your Ds, you could only get them the first chance. You don't have a resubmission for those, okay? And all the stuff I went through here, the LO3, LO4, LO2, LO1, that comes back in this table here at the end, right? You see LO1 is computational methods, right? And it's split up into Ps, Ms, and Ds. The easy ones would be the Ps. The hard parts of the question are going to be the Ms and the Ds. I hope you all understand what it is I'm talking about here, right? Learning outcome 2 is the statistics. Learning outcome 3 is the calculus. This is going to be the hard part of the course. And learning outcome 4 is the dimensional analysis on vectors. This part kind of easy, not so bad. As I said before, we will spend most of our time doing the groundwork for learning outcome 3, because differential integral calculus is not easy stuff. It gets rough, okay? To the back, they have these textbooks that they recommend. This is a classic book, the Stroud. Pretty sure you could get it in any library. You could find, you could buy it online. This book is very accessible. The Stroud and the Booth is a math textbook, a very classic math textbook, covering the engineering mathematics syllabus, right? If you get access to that book, basically 1/3 of that book is what you need to know for this course, okay? Maybe less than a third. It's a thick textbook. It's probably 1,000 pages or something like that. These are some courses here that you're going to do in the future. It depends on what the H&D is offering. It depends on what SBCS has decided to offer you for the civil engineering H&D. Some of these courses you may have to do, some of them you may not have to do. But what they're trying to tell you here is this unit, this Maths for Construction unit, links very heavily to these courses. Later on, you will do these courses. So like, for instance, if SBCS decides to offer further mathematics for construction, then you need to have a pass in this course before you tackle that. You need to have your grounding in maths, because the further mathematics for construction is going to be delved into a lot of difficult mathematics. Maybe you don't have to do this course. I don't know. I'm not sure. But if you have to do any of these courses here, this Maths for Construction unit links to it heavily. Okay. You could get this textbook here. Let me see what this looks like. Engineering Maths Stroud. Let me show you what it look like at least. Where is it? Let me get a browser happening here. So you would see. So we're on Amazon. Amazon have all these books. Search. Really? And I am not a robot. Oh, continue shopping. Right. Engineering maths, Shroud. What this book looks like. So there's a basic and there's an advanced, right? The basic one, this is the 8th edition, right? 71 US. Holy cow, Batman. That was a lot, right? You really need the latest edition, sorry. Well, look, they recommend the 7th edition. Okay, so you don't really need the 8th. If you could get a cheap copy of the 2nd or 3rd edition, that's fine. They have a lot of other more advanced mathematics books, but they recommend the Shroud. I recommend it too, the Shroud on the boot. It has a good level. The way they pitch it is a good level, right? So that's fine. That's it there. That's basically it. So I went through this. I would type up some of this and put it on the course notes page for you guys to see, right? I don't really want to give you the PDF. I don't know if I could give you this PDF, right? So I prefer to type it up and you all will have access to it, right? I hope that's okay for people. We'll talk about it more as the weeks go by.